Hello, it's Keith from Kinvert, and we're going to be doing another quadratic equation. This one's going to have a complex root, and let's take a look at the equation we're going to be solving. 2x squared plus 8x plus 14 equals 4. And the standard form for a quadratic equation is ax squared plus bx plus c equals 0. And as we can see right now, the equation does not equal 0. And so if we were to do this quadratic equation, we would get the wrong solution because our value for c would be incorrect. Let's go ahead and work on getting this into standard form. And we're still going to have 2x squared plus 8x plus, and then let's see, to do this we want to subtract 4 from both sides because we're trying to get the right side to 0. And that is going to leave us with, let's see, 10 for c equals 0. So we've gone from this form to standard form by getting the right side to be 0. Now let's say that this had been, this is not what we're doing, so I'm going to do this like, I guess like this. Had this been like plus 2x, for example, you would have had to also subtract 2x from this side. Does that make sense? The right side needs to be 0, so let's get rid of this. Let's start solving this with the quadratic formula. And again, the quadratic formula is, I'll put it over here, negative b plus or minus the square root of b squared minus 4ac, and all of this is divided by 2a. And again, in our online lesson on this, we have the proof to show why this is true. Let's start plugging in the values. So we have negative b. Well, here's b, here's a, and b, and c. We have negative b, so negative 8 plus or minus the square root of b squared, again that's 8 squared, minus 4 times a, which is 2, times c, which is now 10. It's not 14, it's 10. You need to remember to keep the right side at 0. All of this is divided by 2a, 2 times 2. And let's continue simplifying this. We now have negative 8 plus or minus the square root of 64 minus 4 times 2 is 8 times 10, so we have 80. Divided by 2a, that's 4. And 64 minus 80. So let me just double check that I'm doing it correctly. 64 minus 80, negative 16. So this is the same as negative 8 plus or minus the square root of negative 16 over 4. Now, this is the issue here. This is why we need a complex number for a solution, because there is no real number for which the square root of negative 16 is possible. And so what we do is swap the sign in there, so we end up with negative 8 plus or minus the square root of positive 16 times I. And that's the important part here. That is the imaginary component of this, divided by 4. What's this going to lead to? Well, the square root of 16 is 4, so now we have negative 8 plus or minus 4, because it is 4 squared equals 16, right? 4 squared equals the square, yes, 4 squared equals 16. 4 is the square root of 16. So negative 8 plus or minus 4i divided by 4, and this is going to lead us to the solution. The solution is, so negative 8 divided by 4, the solution is negative 2 plus or minus 4 divided by 4 is just 1. So negative 2 plus or minus I is the solution for this quadratic equation. And remember, this is not the correct value for C. You need to get the right side to 0 so that you can have this in the standard form of ax squared plus bx plus c. Now you can get the a, b, and c values that will plug in properly. B here, right, negative b, negative 8. And then where's our first a on the top? 4 times a, here's that 2. And here's the 2 after we got it to standard form, times 10, which is c. There's our 10. And this is the solution to the quadratic equation, a complex number because it has a real and an imaginary part. And in this case, the real part is negative 2, and the imaginary part is 1. Okay? So this was Keith from Kinvert. We solved a quadratic equation using the quadratic formula, which we had to get into standard form, and it resulted in a complex number as the root for the quadratic equation. And the result is negative 2 plus or minus 2i. So let's quick write out the two solutions. One of them is x is negative 2 plus I, and the other solution is x is negative 2 minus I. Hope this was helpful, and we will see you guys later. Bye.